We're going to solve some problems using the Simpson Rule, but only if the number of partitions, number of rectangles, is an even amount. So I do have one typo. So the integral from a to b of f of x dx is equal to b minus a over 3n. And then we have f of a plus f of x1 plus f of x2, eventually f of xn minus 1, and then f of b, where when you go from x1, from x0 to x1, that's going to be, you added delta x, which is b minus a over n. And when you go from x1 to x2, you add delta x. And then you take f of those numbers. When you go from here to b, you must have added delta x. Now, as you see, I didn't underline everything. The first one, whether you put it or not, you're multiplying the f function by 1. Then the other ones in the middle, they go from 4 to 2 to 4, 2, 4, and then a 2. And it's always going to end up in a 4. Do you have to remember it's going to end up in a 4? No, it will end up in a 4. Just alternate 4, 2, 4, 2, 4, 2. Wherever you end up, you'll end up. And it's always going to be 4. Okay, now let's figure out what delta x is. Well, so first, let's write down a problem. So suppose we want to do, say, the same two problems we did for the trapezoidal rule. Suppose we want to approximate the integral of x squared from 3 to 5, where n is 4. So the first number in front, that is that number, it's going to be b, so let's write it down. It's going to be b minus a over 3 times n. It's going to be 5 minus 3 over 3 times 4, which is 2 over 3 times 4. I think it's a good habit not to multiply out yet, because maybe you can reduce. And if the numbers are much bigger, it's harder to see the reducing. But here, you know 2 goes into 12, 3 times 4. But it's maybe you don't see it with bigger numbers. So b minus a over 3n, that is 1/6. Now, we need to know what delta x is. We need to know what delta x is. It's the length divided by the number of rectangles. It is 2 over 4, because they told us that n is 4, which is a half. So x, and we're going from 3 to 5. So x0 is 3. x1, I add a half. It's 3.5 or 7/2. x2 is going to be 4. 3.5 plus a half is 4. And the next x, well, 4 plus a half is 4.5 or 9/2. And then the next one, well, you add a half to 4.5 and you get 5, which is b. So that's where we stop. Okay. So now I want f of these numbers. F of that number is 9. F of the next one is 49 over 4. F of the next one is 16. F of the next one is 81 over 4. And f of the next and last one is 25. Remember, the first ones and the last ones, you don't multiply by anything. But the other ones, it's 4, 2, 4, and it turns out that's it. And as promised, it's going to end up with a 4 in the end. Okay, so coincidentally, those 4 cancel. Okay, so what we get is the 1 6 in the front, and this number is 32. 49 plus 9, that's 58, plus those two numbers, 30 plus 20 is 50, 2 plus 5 is 57. Those two numbers add up to not equal, but they add up to 115. And the final answer is 115 over 6, which is 1, 9, and 1, 6. Okay, so this night around, oops, again I have that silly error at the beginning. It's approximately. The answer is approximately 19 and a sixth. Let us do the next one. The next one is the integral from 5 to 6 of x plus 1 dx. And here we also want n to be 4. So the first number that goes there is b minus a over 3n. So 6 minus 5 over 3 times 4, which is 1/12. Okay. Now we need to know what we're taking f of. So we need to know delta x. It's b minus a over n. 6 minus 5 over 4, it's 1/4. So x0 is 5. And x1, well, you add a quarter. It's going to be 5 1/4, which is, well, we'll leave it that way. And x2 is 5 1/2. And x3 is 5 3/4. And x4 is going to be 6, which is where we stop. Okay, so f of each of these, well, f just adds 1. That's f of x. Whatever is in the brackets, you add 1 to it. So first I add 1 to 5, plus 4 times, I add 1 to that number, which is 6 1/4. And then 2 times 4, 2, I add 2 times 6 1/2, I add 1 to that, plus 4 times, I add 1 to that, which is 6 3/4. And then I'm at the last one, so I just add 1 to that. Okay, 4, 2, 4. And the first ones, you don't have to write it, but it's just 1. So the rest is, elementary school addition. 4 times 6 is 24. 4/4 is 1 more. In fact, that number is 25 over 4. This number is 13 over 2. This number is 27 over 4. So when you multiply this number by the 4, you just get 25 plus. When you multiply that number by the 2, you just get the 13. When you multiply that number by the 4, you just get 27. And 1 times 7 is 7. So it's something over 12. That's 20 plus 25. Well, that's 45. And this is 33. So we get 78. And if I'm not mistaken, that's 7. No, it's not 7. Well, 2 goes into both of these, so it's 39 over 6, which is 6 1/2. It's 6 and 3/6, which is 6.5. So that is what the area is going to be approximately equal to. Now, it's very possible that it could be equal. The Simpson rule just say, hey, we guarantee it to be approximately equal to. Sometimes it'll be exact. Now, last time we did this integral, we did it separately. That is, we integrated separately. Now this time I'm going to make a u substitution. If u is x plus 1, then du is just dx. So that's u, and dx is du. So this is u to the 1. So it's u squared over 2, which is, well, u is x plus 1 squared over 2. So we plug in 5 and 6. So we know it's going to be over 2. When you plug in 6, you get 6 plus 1 or 7. You square it, you get 49 over 2. And then when you plug in 5, you get 5 minus, you get 5 plus 1, which is 6. You square it, you get 36. So this equals to 13 over 2, which is 6.5, which is exactly what we got. Sometimes gives you the right answers. Are you guaranteed that? Absolutely not. When it's linear, I suspect you are, but you're not guaranteed this. Like the last one, it's all about knowing the formula. Watch these two problems 10, 20 times. Seeing 20 different ones isn't really going to matter. Okay? You're just going to have to understand that. I wish I didn't erase the x's, but you just have to understand that. That's f for 3. This is f for 3.5. That's f for 4. That's f for 4.5. And that's f for 5. And then you're going to have 1 and then 4, 2, 4, maybe 2 and 4, and then 2 and 4 again, and then end with 1. But before the last one, it will be a 4. So that can be your check. Maybe you forget if it should be 2, 4, 2. 2, 4, 2, 4, 2, 4. Well, that's the problem. 2, 4, 2. Oops, it's not ending in 2. Ah, yeah, I remember. It's 4, 2, 4. Okay, as I said, that completes this video for Simpson's rule when the number of rectangles is an even number.